In this video, we're going to introduce a new keyword called this, THIS. In Java, this keyword is a reference to the current object within a methods or constructor. It could be used to refer to any member of the current object, including fields, methods, and constructors. So if you have an instantiated object from a class, let's say created in a heap using the new operator, or if you simply just declare a copy of it, let's say circle C, this object will be in what's called the stack memory. Either way, when you have an object sitting inside either memory spaces, you can use the this keyword to reference that object itself. Typically, this is being done inside the object's constructors or methods. We'll also look at this use case where another common use of this is to enable a constructor to invoke another constructor of the same class, because this refers to that object. Let's look at a quick code snippet to understand the second use case here. Let's look at this example using the this keyword to enable a constructor to invoke another constructor of the same class. This is the process commonly known as constructor chaining. Overall, we're dealing with the same object. However, constructor is called twice. They're different constructors though. Let's look at this one line at a time. Constructor one, which is your default constructor, when invoked, it calls this with 0 in it. Noting that this is really the myClass object, or the object that is being instantiated at this moment. It calls another constructor that has a 0 value, which is this, defined as a parameterized user-defined constructor with a value parameter. So constructor one calls constructor two using this 0. It passes the value of 0 as an argument to constructor two, which is this. Constructor two, which is the parameterized constructor, initializes the value field with a provided parameter, this dot value value. So basically this value gets initialized with a value of 0. As you can see, we're dealing with the same objects here. But what we're doing is we have constructor one chaining it with constructor two. Now, a lot of times developers don't specify default constructors when constructing an object. Therefore, using this chaining mechanisms, it ensures that certain values are initialized, even though developers or the calling method didn't specify it when instantiating this class. This reduces code duplications and ensures consistent initialization of objects within the same class. You may ask, why wouldn't we just bring this in here and eliminate the need of having this, or even the need of having a constructor two? You're absolutely right. You could. A lot of these choices and decisions are made at design time, software design, that is. You can certainly do one way over the other, but there are use cases out there that calls for constructor chaining, and this demo illustrates the use of the this keyword to enable that chaining. Let's look at some of the other examples that demonstrates the use of this keyword. This is another example illustrating the use of the this keyword. When a local variable has the same name as an instance variable, the this keyword can be used to refer to the instance variable, which means this I and this I, even though they are the same name, to not confuse with the instance variable I with that of what gets passed in, you would write this dot I equals I. This is done on purpose to, one, illustrates that this I is really for this I, so there's no confusion. Ultimately, you can change this I to, let's say, K. It wouldn't have matter. It just makes the code a lot difficult to read. Noting that sometimes we may have static variables. Remember, static means there's only one instance of it. Static also means that this K, static is not of the instance, but of the class. So you have to use F, which is the class name, dot K equals K, instead of using this. Remember, this is for the instance, static is for the class. These are the differences. Noting that we have F1 and F2, these are two instances of the same class. They occupy different memory spaces, F1 and F2. So when you do this dot I inside F1, this refers to F1. Same thing when you do this dot I inside your F2 instance, this refers to F2. In summary, this refers to the instance it belongs to, not the class or anything else. You can use this to refer to that instance method as well, in addition to using this to point to this data. This is also a very common way of invoking its method. Sometimes you can get rid of this, especially this is done inside the same class anyway, and assuming this method has visibility to be seen by other methods inside the same class, then the this keyword is not needed. But for code readability, a lot of times you would add the keyword this dot methods to make the code a lot easier to understand by others. Let's look at another example. What we're looking at is our circle public class, which has a private radius data, one user-defined parameterized constructor that takes in that radius, one default constructor, and a public method. This parameterized constructor takes in the radius. Notice we have this dot radius. This refers to the instance of circle that's being instantiated right now. Dot radius refers to this radius. You can do that because we're doing this as in a class, and class has access to private data. So this dot radius equals radius means the local radius that gets passed in is assigned to the radius internally. As we stated before, we keep the naming convention the same to make the code a lot easier to read. So you wouldn't want to change this radius to XYZ. By convention, you use the same naming convention, period. This example in the default constructor is what we call earlier the constructor chaining. This basically calls another constructor with a parameterized double, which is this. So by invoking or instantiating a circle via its default method, it also initializes the radius to 1.0. Doing this is a little more convoluted than if you were just to write this dot radius equals 1.0. But a lot of times you want to separate this, and without hard coding this, you can focus more of your attention on defining newer constructors that take some defaults to make your code a lot more modular. This is more about making the software design decisions. Let's look at this third examples where we have this public method that takes in this dot radius. Remember, this method is sitting inside this class, which means this private data variable could be seen by the class, making use of it. You don't really need this. In fact, you can get rid of this dot and just keep the radius because you're doing this on a class level, not instance level. Radius times radius time will compile as well. Sometimes we keep it just for the sake of uniformity, so there's no confusion as to which radius we're talking about. So you will use this dot radius as is illustrated here. This should complete the discussions on the this keyword in Java. In summary, the this keyword is a powerful tool in Java for working with object-oriented concepts. This keyword also exists in other OOP languages. They allow you to reference the current object and its members in a clear and concise way.